Okay, good day to everyone. So today we'll be taking a look at the question on functions. So in this function, f is being defined to be fx equal to 2x over x minus 2 for all real values of x except for x equal to 2. So maybe I can rewrite the equation here. So my fx will just be equal to 2x over x minus 2. So part A of the question is asking you to sketch the graph of f and to find its range. So usually before I sketch the graph using GC, I will just analyze some of the features first, like the intercepts and the asymptotes. So probably the first step I will do is just do a quick long division first. So I will get 2x minus 4 over 4, and I can rewrite my fx to be 2 plus 4 over x minus 2. So from here, I will be able to identify what is the asymptotes. I can see there will be one vertical asymptote at x equal to 2, one horizontal asymptote at y equal to 2. As for the intercept, I will just let x be 0. I can see that I will get y equals 0 when x equals 0. So also when y equals 0, x will be equal to 0 also. So I know that this particular curve will pass us through the origin. So from here, maybe I can just use my GC. Okay, I have already sketched it out here. So the equation here, so I graph it, I'll get this curve. So now I can do a quick sketch. I will get my vertical asymptote here, x equal to 2. Horizontal asymptote, y equal to 2. So my curve will be from here to here, and from here, and it will pass us through the origin. Okay, so I get y equal to fx. And from here, I should be able to determine what is the range of f. In fact, the range of f is every single values of y except for y equal to 2. So I know that range of f will just be everything except for 2. Next part of the question says you are given the function of g defined to be 3 plus modulus x plus 2. Maybe I can just write the equation down first. So gx will just be equal to 3 plus mod x plus 2. And the domain is defined to be every single values of x. Part B says that show that the composite function of fg exists. So for fg to exist, okay, the criteria I know will just be range of g must be subset of domain of f. All right, if you can't remember the criteria, you can just imagine the schematic, which is imagine the function of g to be like a black box. So in this case, right, the function of g will be the first function, and function of f will be the second function, and the function of g will go into the function of f. So I can just imagine this will be the function of g. So input will be like domain of g, output will just be like range of g. And for the function of f, it will be this, similar. This is the function of g. And we can just think of this like the domain of f. So in order for the composite function of fg to be defined, you can see that the range of g, which is the output of g, will be or must be contained within the domain of f. All right, we cannot have some values that is not accounted for. Every single value of the range of g must be all fully contained within the domain f. That is why we'll have this particular criteria here in order for fg to exist. Right, so we need to find out what is the range of g. Okay, maybe I can just do a quick sketch for the function of g. So function of g, I can just draw it here. The base curve for this expression here is mod x. And we know that for y equal to mod x, the graph looks like this. So basically, I'm doing translation of 2 units in the negative direction of x, followed by translation of 3 units in the positive direction of y. So my final curve, I will get, it will look something like this. So this will just be y equal to gx. Maybe I can just label this point here. It would be minus 2, 3. Okay. This point is not necessary, but maybe I can just label it quickly. So this is the y-intercept. So from this diagram, I can see that the range of G basically will just be from 3 all the way to infinity, inclusive of 3 and excluding infinity. So it will be from inclusive of 3 all the way to infinity. And domain of f is given to be all real values except for 2. So therefore, we can see that this particular region here will all be fully contained within this. So therefore, the composite function of fg exists. So therefore, fg exists. And next part of the question says that you're supposed to find the expression of fg. So finding the expression of fg basically means we are putting the function of g into the function of f. So what we are going to do here is we will be just replacing all the x we see with the function of g, because it's the function of g going to the function of f. So my function of fg will just be 2 replaced with gx, 3 plus mod x plus 2 mod over 3 plus mod x plus 2 mod minus 2. Simplify, I will get 6 plus 2 mod x plus 2 over 1 plus mod x plus 2. Alright, so we also need to find out what is the domain. So domain of a composite function will always follow the domain of the first function, which happens to be function of g in this place. So domain of g, I can see it will just be everything is given to us. It's the value of x element of all real. So it will just be all real. How about range of fg? Alright, for finding the range of a composite function, a lot of students actually mistaken range of fg is the range of g or the range of f. In fact, it's not true. Although there will be certain cases whereby the range of fg happens to be range of f. But in general, we cannot assume it to be true. So the best way of finding the range of fg is to either sketch out the graph of the composite function, which I have here. In this case, I probably will not want to do it because it looks very complicated. All right, the second way I'll be doing is I call it the mapping method. So basically means to find the range of composite function fg, I'll be looking at what is the new range of g that goes into the domain of f. You can see here is the new range go into the domain of f. So the range of g will probably be a subset of domain of f. And this will be defined to me to be the new domain of my function of f. It's just like using the range of this paste into the domain of the outer function. So from here, you can see that from 3 to infinity is the range of g. So this range will be putting into the domain of f. So I can just imagine that it will be pasted into the domain of f here. All right, so this point will just be 3. All right, so for this new domain, I want to see what is the new range that this function will take. That real range, right, will just be the range of the composite function. All right, so from here, if I were to sub in the value of 3, I can see that f3 will just be equal to 2, 3 over 3 minus 2, which will give me 6. So I know this one will be 6. All right, the new part of the curve which I want to analyze will just be this particular part here. And this will be the new range that it takes, and it happens to be the range of the composite function. So from here, I can see that the range of fg basically will just be from 2 to 6, excluding 2 and inclusive of 6. So the final answer will just be excluding 2, inclusive of 6. Right, so that will be my range of my FG. Okay, so that's the final answer for the entire of part B.